Okay, class, today we are going to be continuing our lesson from section 10.3, arcs of circles, arc length, and today we're going to be moving on to sectors of a circle. All right, so before we can dive into the sectors, the area of a sector, we need to review what and how to find the area of a circle. So what is the area of a circle? The area, remember, is if you were to fill in your object, how much material would we need to fill that in? Okay, so reviewing the area of a circle, you need the radius, and the area formula is pi r squared. Okay, so pi times the radius squared. All right, so we're going to do a little application problem over here. For this one, you have a circle, and inscribed in it is a quadrilateral. And the question is, what is the area of the shaded region if the radius of the circle is 2.5? So this being 2.5 and this being 2.5, which means this whole length, I'm going to use that instead. If that whole length is 5, interesting. Okay, so in order to let's do a little bit of predicting here. How would I find the shaded region? Well, if you look at the overall figure, it is a circle. And again, the unshaded region is, it's a quadrilateral, but it's also, you can think about it as two triangles that are definitely congruent. If you look at the side theorem, we know that the two triangles are identical because they mark the sides equal, and by the reflexive property, they share what's actually the diameter of the circle right there. They share that component right there. Okay, so if we can simply find the area shaded, and I'll write this like this. If we can find the area of the circle and subtract the area of, well, we haven't gotten into finding the area of quadrilaterals yet, but we know how to find the area of a circle, and they're both the same. So if we can find, or not the circle, the triangle, we can find the area of one of those triangles and then double it. And by subtracting the unshaded region, which is the two triangles, we will be able to find the area of the shaded. Okay, so first let's find the area of the circle. So if we recall, the area of a circle is pi times the radius squared. Now I do 2.5. If we want to do this without a calculator, 2.5 is the same thing as 5 halves. It's just a little bit easier to work with. And then we're going to do 2 times, remember the area of a triangle is 1/2 the base times the height. And I would recommend, rather than finding the height and using 5 as a base, we have this structure right here. And let's talk a little bit about that. If you notice here, we have marked in our illustration that these two sides are equal, and I'm going to focus on just one of them. Being that this has a length of 4, what I'm going to do is I'm going to take that 4 and just put it right here. And what I want you to notice is that this has a length of a 3, this has a length of a 4, and this has a length of a 5. Now, we learned back in the very beginning of chapter 9 what's called a Pythagorean triple. 3, 4, 5 was one of those very special triangles that we talked about, in which this, if this is a 3, 4, 5 triangle, then this would have to be the right angle, all right, in which they gave you that side there. Okay, so we have a right triangle. So that means that we can find the area of this right triangle, and we could take these two legs, which would be your base and your height. Or if you recall, we learned 1/2 of leg times leg. Okay, so the area would be 1/2 of 3 times your 4. And then now we could just simplify. And we end up with 5 squared is 25 over 4 pi. And then I can find the area of one triangle. Half of 12 is 6. And then when you subtract, your final answer is 25 pi over 4 minus your 12, and then your meters squared. And voila, that is your area of the shaded region. All right, so when you're doing these problems in your homework again, you're going to always ask yourself, what is the overall outer figure? And then identify what the unshaded figure is, and then you can subtract one component from the other. Okay. All right. So now we're going to move on to what does it mean to be the sector of a circle. So the sector of a circle, you want to think about a pizza. Okay, so a sector is like a piece of pizza. All right, and we're going to be asking to find what is the area of part of the circle, or how does a part of the circle relate to the measures of the arc of that sector. All right, so just like we did before, we're going to set up a proportion. And we know that the ratio of the area of a piece of the pie, which is what we call a sector, to the whole area, that ratio is the same as the measure of that piece of the pie to the whole pie's measure of 360. So the beauty, just like we did from the previous set of notes from the first part of our notes today, we really just need two of those components because 360 will always be the same. We're going to potentially be solving for the area of the sector, or maybe we're going to be looking for what is the measure of the arc of that sector given its area of a piece of the pie. All right, or we might be solving for the area of the circle. So we're going to do a couple, get some practice similar to what we did before. Now remember, when we did the arc length, there's going to be two ways that you could solve this. So one way is to start by finding the actual area of the circle. All right, so we're going to start by doing that first. Area equals, remember, pi times r squared. So the area of this whole circle would be 25 pi. Remember, we're going to take the radius and square it, and then multiply by pi. So the area is going to be 25 pi. And what we can do is find the area of just one part of it. And to get the other parts, the other sector's area, simply subtract it from 25. Or you can simply solve two separate areas, the little arcs area, the big arcs area, using a proportion to solve both of them. And then always double check your answer. When you're all done, do they add up to that 25 pi? And that's one thing you always want to do. The sum of these two, the large and the small, should add up to 25. And that's a quick way to check your work. And the same thing with the circumference. When you get to your two arc lengths, you should always go back and add them up and check. Okay. All right. So let's go ahead and do this. For this one, again, I do recommend getting both of your arc measures between the two of them. All right. So we're going to have this minor one. Well, I guess we'll use blue. And then the major one over here, we're going to need both of those. 360. You're going to subtract your 63. And over here, you get 297 degrees. For that inner, okay, or for that central angle, which is going to be the same thing as that measure. All right, so let's go ahead and we're going to set up a proportion and we're going to solve. And in this one over here, we want to know what the area of both of them is. We want to know what that shaded region in blue is, and then we're going to want to know what the area that rest of the pie is as well. So it really doesn't matter which one you start with, what you want to work with first. I'll probably just go right for the blue one, the proportion that's going to allow us to solve for the exact area of the blue sector. Okay, so let's go ahead and do it. So the area, and I'm going to use A for area, the area of, I'll use S for small, divided by the whole area of the circle is 25 pi, and that equals the same ratio of 63 degrees divided by 360. Okay, so now in order to solve for the area, we're going to take 25 pi, and we're going to multiply both sides of our equation by 25 pi. These will cancel out, and we'll end up with the area of the small sector is equal to 63 degrees divided by 360 degrees times 25 pi. And go ahead and simplify that all the way down. I'll give you guys a couple seconds to do that. Ask yourself what goes into the top and the bottom evenly. We do know that we can divide the top and bottom by 5. Keep going all the way down and let's see what you get. All right, you can pause me if you want. At the end of the day, the area of the small sector ends up on being 35 pi divided by 8 and then units squared. And that is that value right there. So now if you want to get the area of the large, again, you have a couple different methods as how you would go about solving for the other sector. I would say the recommended would be this method, method 1, which would be to take the area, let's see, the large one would be taking the area of the whole circle and subtracting the area of the small. And again, it is always going to require that you do find a common denominator when you put them together. All right, so the area of the large one, so area large is going to equal the area of the whole circle, which is 25 pi units squared, minus the area of the small, 35 pi divided by 8 units squared. And in order to be able to put those together, you do need to have a common denominator. So you're going to multiply the top and the bottom by 8. Okay, and then you'll end up with 8 times your 25. You're going to have 200 pi, and I can put them together right now, and 35 pi all over 8 for a grand total of 165 pi. You know what? I'm just going to go ahead and put it right down here. 165 pi over 8 units squared. Okay, so there is your large area. And again, I want you to go ahead and check your work. Adding these two together, you would end up with that simplifying down to 25 pi. All right, and again, your method 2, if you were to do this one, method 2 would be to solve the proportion all over again, and you would have the area of the large over 25 pi is equal to, and now instead, 297 degrees, all divided by 360. And when you solve, you should get that value right there. So it's your choice, whatever method you want to do. Okay, and the last problem that we have over here is use the diagram to find the exact area of the whole circle. And notice they gave you a chunk, one piece of the area. So the proportion we're going to solve for is part of the area divided by the entire area of the circle is equal to, be really careful here. That 315 is not the measure of that piece of the arc. You need to find what this value is right here. And you're going to take 360 minus 315, and this is 45 degrees. So you want to make sure that you have the right arc right there that corresponds. Go ahead and solve that. I want you to go ahead and do that. Put me on pause, cross multiply. You're going to go ahead and solve it. Pause, pause, pause. Solve it, please. And at the end of the day, when you're all done, you should get 176 meters squared. Okay, so that is the entire area of your circle. So now if they ask you what is going to be the radius of the circle, we know that the area is equal to pi times r squared. you can simply substitute 176 in for the area. So we can do that right there. You get 176 equals pi radius squared. We're going to go ahead and we're going to divide by pi on both sides. Okay, so you end up with 176 divided by pi, and then taking the square root of this value. Boop, boop, boop. There you have it. But again, it is not considered to be simplified if you have a square root in the bottom. And then again, you always want to double check. Can 176 be broken down into a perfect square and another number, and which it can be. All right, so play with your factors a little bit, and let's see if you can rationalize a denominator and get the appropriate answer. I'm going to pause it right now and see if you can get that value. All right, so again, pause, and then fast forward. And hopefully at the end of the day, you realized that 176 can be broken down into 16 times 11, and then rationalizing the denominator, you have times the square root of pi on top divided by pi, and this simplifies down to 4, and then you can combine the square roots of 11 and pi together, all divided by pi. Whoops, not 4. All divided by pi. And there's the radius as a simplified radical by rationalizing the denominator as well. Okay, so at the end, they may someday, you never know, ask you what is the area of the large, and we're just going to do a little side note, the area of the large sector, so let's say this one right here, you would simply have to take the area of the circle and subtract the area of the small, which we know is 22. So the large sector would be 154 meters squared. And again, they did ask find the area of the large sector as well. So you just simply have to subtract those. So we have multiple things that we found here. We found the area to be 176. We found the radius, and we found the area of the large. Okay, there you have it, you guys. Have a wonderful day.